Hello everyone. Today our group will present the mini project for knowledge-based system, and our title is PC Doctor, a knowledge-based system expert system for hardware and diagnostic. For the introduction, the need for PC Doctor. First, personal computers are integrated to daily life for work, education, and entertainment. Hardware failures are common but difficult for non-experts to diagnose accurately. Then the misdiagnosis lead to unnecessary repairs, increase the cost, and extended downtime. And for our solution, PC Doctor is a knowledge-based system KBS designed to simulate the reasoning of a hardware expert. It guides user through a structure diagnostic process via simple question. The system provides clear conclusion, technical causes, and actionable recommendations. And for our project problem background, the first common hardware issues, the power supply failures, and then the memory RAM's error indicated by vscode, and then the disable problem like no signal, artifact, and BSOD. And the last hardware issue is BIOS and CMOS battery failures. Why traditional troubleshooting is failed? Users lacks technical expertise, and online guides are often generic and confusing. Technician service are costly and time-consuming. So for the knowledge gap, there is a disconnect between user symptom and expert diagnostic logic. So the PC doctor will become the bridge for this gap using the rule-based reasoning. For the objective part, PC Doctor will provide a user-friendly interface for entering computer symptom. Secondly, automatically diagnose hardware issue using forward change rule. And the third one, generate comprehensive diagnostic reports with technical causes and recommended actions. And the last one, reduce the dependency on expert technician for initial troubleshooting.
Okay, my name is Subramaniam. So, moving on to our data collection, the intelligence of this system is built on three pillars: expert interviews with IT specialists, technical documentation regarding post-bit codes, and standard industry practices. As you can see in the table, we use a structured mapping process, which is systems. We look at the physical cues like power setters, bit patterns, and string artifacts. Second one is technical cost. The system translates these symptoms into a specific failures. For example, identifying that string long or bit code indicates a RAM parity error. So we have included recommend action. Finally, it provides a clear solution such as a reset or replace RAM, moving to user from confusion to concrete fix.
Next, I'll talk about the methodology used to develop the PC Doctor expert system. First, knowledge acquisition was done through IT expert interviews and technical references to identify common PC symptoms, causes, and solutions. Next, rule formation converted this knowledge into if-then rules with priority given to critical faults such as power failures. Then the rules were implemented in clips where templates and initial facts were defined to guide the diagnostic process, and the system uses forward chaining, meaning user inputs are treated as facts and rules fire automatically to reach a diagnosis. Finally, testing and validation were carried out using multiple test cases with invalid inputs handled through re-prompting. So this approach ensures accurate and reliable PC fault diagnosis. Next up, this slide shows how knowledge is represented in our system using a tree-based forward chaining approach. User inputs are first captured as system facts. So these facts are then evaluated by the inference engine using forward chaining. So each decision node in the tree represents a rule evaluation where the system checks conditions such as power issues, memory errors, or display problems. Rules fire automatically based on matching condition and their priority, ensuring critical faults are handled first. Finally, the leaf nodes of the tree produce the final diagnostic conclusions such as identifying hardware failures, or system configuration issues. So this structured reasoning flow allows the system to diagnose PC problems logically, consistently, and efficiently.
Hello everyone, my name is Kirtigan son of Balu and my metric number is B0323108873. Today I will briefly explain the structure and design of our clip-based expert system called PC Doctor. First, templates here defined using def template uh, to represent our symptoms such as PC power status, beep code, display condition, and system time error. And next is facts here initialized using def fact to represent the initial state of the system. This allows the inference engine to know where to begin the reasoning process. Then uh, production rule here written using def rule. So these rules are responsible for asking diagnosis question, validate user input, generating hardware fault conclusion. The system consists of two main type of rules, control rules and um, diagnostic rules. In total, the system contains around 15 rules covering power issue, beep codes, and digital problems, and so on. All rules follow if then format which represent expert knowledge clearly. To control the reasoning flow pace such as ask power, ask beep, ask time, and generate report here implement. Overall, the system applies forward chaining starting from user input and automatically delivering conclusion. So here can see the result. So we can see 4 question. So first, does the computer power on, beep code, screen status, is BIOS date or time incorrect? So answer this, I can see the where the fault and the solution. So if but you can see here only 3 question because the fourth question depends the question 3. Question 3 is screen status is normal, only the fourth question appear. If other than the fourth question didn't show because if screen status is normal, then can see the BIOS time or date. If not, we can see the blue screen or black screen. And then you can see if user input invalid, so the system will detect and show the correction invalid, use either yes or no. Testing more than 10 test case here conduct covering all symptoms combination. The system achieve 100% accurate for all predefined hardware fault, responded almost instantly and handle invalid input gratefully through reprompting.
Okay, now to conclude, our system has proven highly effective at accurate hardware diagnosis using forward chaining logic, meaning it systematically works from symptoms to solution. It even supports the detection of multiple hardware issues at once. So, however, we recognize some limitation in our project. It currently relies on manual user input, which can lead to human error. It is restricted to predefined hardware issues, excluding software or OS level bug. So, looking ahead, our future improvement will focus on automation. So, it can integrate hardware scanning to reduce reliance on user input. So, second one is scope. So, expanding the rule base to include software, drivers, and peripherals like printer and drivers. So the third one is UI, developing a full graphical user interface to make the tool more accessible to non-technical users. That's all from our team. Thank you.